Okay, so we continue our data and artificial intelligence journey. Okay. So this is another example. I think you must have already been warned, or you must have already seen. Even you must have already seen the fight on the public transportation that everyone was warning each other about the use of mask, or you need to wear mask because you may pass this on to your others, your disease, COVID and whatever. So wearing a mask was quite important. But how could you detect that somebody was not wearing mask or was not wearing mask properly? So it could be uh, detected using all different cameras in and around you, and you may be able to decide, make a decision on whether this person is masked, this person was not wearing mask, whether that person was wearing the mask properly, and so on. But the data needs to be fed into big artificial neural networks to learn from the data that you have. So you need to collect data from different people, thousands of people, maybe millions, from different angles to be able to detect if that person acting properly according to the mask rules, regulations that we had during the COVID time. So it could be applied to different fields. Even this could be also used for different purposes, even in the historical buildings, whether that part of the historical building was actually a genuine one, or it may have been put in the different period of that history. So I think this depends on the data that you collect and the way you learn using the artificial neural networks. This is another example, looking at multi-sensor fusion data. The reason why I want to show you, because in the architecture, design, and restoration, you need to collect data coming from different sources. And this data needs to be fused into an algorithm to make a better decision for different purposes. For example, reprinting of the building's part, or collecting information from the historical sites and turning into knowledge for different purposes. So this robot is called Pig, and it has hundreds of sensors on it, maybe a couple of hundred, maybe 600, and it goes through the big pipelines, very big pipelines. It's not used, for example, the one that you see in your houses or flats. So what happens here is that it goes through the pipelines and detect whether there's a leakage or not, and whether whether there is a crack or corrosion and so on. Can you imagine if there is a leakage? So you lose petrol, you lose gas. If there is a big leakage, then you would even lose more. Another thing is that if there is a big pressure in line with that leakage, that part of the pipeline may burst out, and then you would lose that part of the big pipeline. So you need to be able to detect everything in hand just in case of protecting your pipeline, your asset, because petrol and gas is very expensive materials. So this is a typical data set coming from each sensor on the robot or pig, as you mentioned, and you can see what is likely to be there. So you need to learn from the data. So it's a typical one. There may be leakage here. There may be corrosion here. So the data scientists, are going through this manually to be able to detect this happening. So for example, these are the real pipelines. For example, this one is at 275 kilometers of the pipeline, and there are more than 500,000 boxes that you need to inspect as a data analyst. Can you imagine that if data analysis spends 1 second per box, this would take more than a month to complete this inspection, this analysis, given the normal working hours and days over a week. So this is a massive job. This manual job is a massive job. And the other thing is that there may not be a consistent. The reason is that the focus of an individual, a person, may vary from one time to another time. So the consistency may be lost, and that person may lose or may not miss a leakage or artifact on that pipeline. So this is an example. Actually, it was detected by the algorithm that was developed but missed by analysis. You can see that. So the analysis put this in there, and then the algorithm detected. So this is where artificial intelligence, machine learning, and data collected over time have helped in different domain, in different structure, different ways. So, but the analysis, the human analysis would be used or deployed on another more complex tasks to complete. I think this is particularly important, and also this such algorithm, such AI-driven tool can also or has helped us to maintain the consistency over different inspection. Okay, so this is another one about the fintech or within the context of shopping habit, and also this is linked to even architecture, because you want to attract your customers to come and visit your architecture building sites, and you would be able to show them what it is there, and also through that money that you have raised through this visit, your architecture restoration may be better because of the monies that you are raising. So this is called a hybrid two-level support vector machine-based method for churn analysis. This is linked to the pricing. So actually, the pricing or a pricing something, a product, a good, is a personal and based on value judgments. So you need to optimize the price to be able to attract your customer, to convince that they should buy your product or services, for example, mobile phones or mobile phone services. And this needs to be intelligent, automated, personalized pricing scheme. So, I mean, if you look at the literature, people who are really good at pricing gives you a hint about how pricing should be considered. So pricing strategy has always been more of a poker game than a science. So, but if you have a data, so rather than a poker game, but it may become a science. So data science would be able to help you to optimize your price, and your customers may be willing to pay for that service or good or product. So another one said successful pricing is more of an art, not a science. So actually, yes, data science is another aspect of art. So you can use data science to create an art or make it art. Another one said pricing decisions are not easy to make. Yes, absolutely right. It depends on several different factors, and they are often inherently soft. Yeah, so you can make it soft, but you can turn your data into a pricing tool, and you can make it flexible. So the purpose behind this is to be able to segment your customers based on their behavior and purchase history. I think this is particularly important because data is coming from each of your customers. It's like a social network. And then you can turn this into a product that may determine whether that person is going to purchase your product or is willing to purchase your product, which product at which price. So this is particularly important. So you need to know your customers, and this is where you can use data science and artificial neural networks to identify the clusters of these customers with a similar behavior, and then you can identify which products are preferred by which customers or set of customers or clusters of customers and when, because selling a product at the right time is also important. And then you can make a price suggestion for products and customers when it is right. So artificial network data science, based on data you have collected, can give you this piece of information. I think this is another way you can harness your data to help your clients. So let's try to describe what we mean by churn, because churn analysis is linked to pricing. Churn, if you are trying to keep your customers within your company, this is particularly important and actually more affordable than, easier than you are trying to win new customer. And this is what is described in the literature. So when we look at the churn analysis, due to the diversity of the customers, products, and services, and massive amount of data being generated as a result of e-commerce tools and services, data analytics and artificial intelligence machine learning algorithms have been developed and used for churn analysis in order to develop a strategy that is expected to understand the reasons behind the customer churn and subsequently develop an effective and profitable customer retention program. So you want to keep your customer to keep buying your purchases. This is particularly important. So you don't want your customer to go away. So basically, this is another digital twin of your customer that you need to create based on the data that you have, the historical data. So analysis based on the data analytics and artificial intelligence methods focuses more on the profiling of customers, like segmenting, or this customer may do this one, or this customer may be similar to the other customers, and classification of customer churn, identification of the features that affect the churn. But yes, you come up with a customer behavior models and customer segmented customers and put them into a group or groups. So what are you going to do then? So you need to identify whether that customer is going to purchase this, or whether how much that person can spend for goods or services. So when we look at the literature, I mean, data was or doesn't seem to have been used to look at whether how much that person is willing to pay for that service or service. So in that case, we should be able to predict how much a customer or group customer uh, may be willing to pay for that service. So I think this is particularly important. So grouping of customers is particularly important, but I want to know how much that person is willing to pay. Then I would offer that price, and I would like to keep that person in my company. So therefore, we look at identification of the customer churn or not, whether that person has left the company and gone to another company, for example, mobile phones, and then another one that I want to do is to be able to predict how much the customer is likely to pay for the service that I offer. So this is the model that we are going to describe here and we worked on. So we have all the churn data with all the features, and we are going to have a churn classification using an artificial neural networks, artificial intelligence model, which is called support vector machine. And then this algorithm will tell whether the customer has churned or not, yes or no. Another analysis that we have done is monthly charge. So the payment per month, how much that person is likely to pay. So actually we have this data. We are going to use data to learn the model, and for future customers, then we'll predict whether they churned or not, whether the customer was retained in the customer or left. And then also we are going to predict how much that person or that customer can pay or willing to pay. So another thing that we need to do is to be able to select the features of the algorithm, because if you look at the examples that I showed you before, there may be too much information, there may be noisy information, there may be minimum information that may not be enough to predict what you need. So, and also if there is a noisy data, if there is too much data, then you need to filter this out, because not every piece of information that you have in your data set is the best one and help you increase your accuracy. So therefore, you need to select some of the features that may give you the best outcome, because not all the features in your data set may give you the best outcome. So therefore, the data is passed on to a feature selection model to identify which features are the best, the optimum, and then do this calculation again. So first decision on churn, whether that person churn or not, and also predict the price per month. And this is the data that we use. So there are 21 features collected from each customer. Actually, the data set was publicly available, and it's called IBM's data. And then customer ID till churn. So the churn is yes or no. This is going to be used as an output. And also monthly charge is again used for the output. And the rest is going to be used as an input. Customer ID is not important as a significant feature because it's just the ID used to anonymize the customer. But the others, for example, can gender affect the output? I will see. And whether that person is senior citizen or not, it's like very old people, we don't know. And does that person have a partner, dependents, mobile service, multiple lines, and so on? They are all different features that may have affected our decision to stay in the company and to pay for certain amount per month. So this is quite interesting. What we discovered from that data set that, for example, there's a gender balance, more or less, so 50% for both cases, churn yes or churn no. And what we can see here is that total average charge, you can see different people and different amount of value per month. And if you look at the number of senior citizen churn, yes or no, you can see the difference between them. So it means that actually senior citizen and having multiple line users have a different behavior in terms of purchasing history as a customer. So if you look at the difference between male and female, for example, average monthly price, if you look at the churn, yes, you can see there is not much difference. And if you look at male, again, you can see that there is not much difference here. But if you look at, this is for monthly, if you look at the total charge over a period, for example, a year, so you can see the difference, a slight difference between male and female. And okay, again, you can see the differences between senior citizen and also having multiple line users. It means that this is a snapshot of how different features may have a different effect on churn, yes or no, and monthly price. So it means that not all features have the same weight for the output, for the prediction of churn or not, and the prediction of monthly price. So therefore, there needs a better methodology, not the manual one like I showed you, better methodology based on artificial neural networks to be able to select the best optimum features. So based on the analysis that we came up with, for example, we use, as I mentioned, support vector machine with all the features. We reached accuracy of 80%, and also we reduce it down to 17 features using a feature selection method. We got slightly better accuracy. So it means that by reducing 2 features, we got better result. The other features don't seem to be that much good. So they need to be eliminated, withdrawn from the model. And we managed to get a bit higher accuracy that was presented in the literature before. But this was done in the literature. But what was not done in the literature was the prediction of monthly charge. And again, we applied a similar way and a slightly different version of support vector machine. This is called support vector regression with all the features. And we got the error, root mean square error of 1.27. And with the 10 features, actually the algorithm gave this as the optimum features, and we got higher error. So it means that for the prediction of monthly charge, I would use all the features. For churn analysis, whether yes or no, whether the customers churn or not, then I would use 17 features. So it means that depending on the application, the way you use data is different because of the algorithmic architecture. So now I have given loads of different examples of the use of data, the importance of the data, the quality of the data, and different types of data, and how they have been used in different domains to achieve your aim, and so on. So, but the governments have been working on that area and generating a number of different papers, white papers, and reviewing the sector and so on. So, for example, 2021 UK strategy innovation UK innovation strategy was published, and in August 2021, nearly 2 years ago, impact review of Innovate UK's AI related activity was published. This is where they talk about the AI sector in the UK. And then As briefly mentioned, a national AI strategy was published, and data strategy for defense was a specific and interesting example of the importance of the data, highlighting the importance of the data was mentioned, and how and which type of data could be further used for defense purposes, and so on. So you may be able to find different things in your own country, but this is particularly important for the use of data. So I think without the data, artificial intelligence, machine learning algorithms are difficult to train and reach the optimum and behave like a human being. So the more data you have, it can become better. So finally, now we are talking about net zero strategy and how you can make our planet greener because of different reasons. Where data and data linked, artificial intelligence linked, and digital equipments play a role here. So I may be able to touch upon this later. Thank you.